Welcome to another video. Today we are looking at a SL paper, paper 2, TZ1, and it's also a new exam, 2019 May. And to be honest, this year exam for SL is pretty hard. And yeah, that's the reality. It seems to be getting harder and harder. And obviously, we have a syllabus change soon in 2 years. So if you ask me, I'm gonna predict that it will at least remain this difficult. But let's jump into the question. This question is mixing some y equal to mx plus c line with the equation of strict line in vector form. So it's a mix of normal coordinate geometry with vector geometry. So you need to be pretty good at these concepts to do this question. Okay, let's see. So the first part should be standard. There is a tangent to a function at a certain point. So to find that, obviously, we want to differentiate the function. So we're gonna obviously write 16 over x as 16 times x to the power minus 1. Therefore, when you differentiate it, you drop down the minus 1. So it's minus 16 x to the power minus 2. And then you sub in x being 8. Okay, this is paper 2. You may use a calculator. You should get negative 1/4. Okay. Now then the next thing is they're saying that this line have a vector equation of r equal to a2 plus tu. Obviously, if you're familiar with the vector equation of straight line, this is in the form of r equal to a plus tb, where a would be a position vector, which is just a point on the line, and b, which is u here, is supposed to be the direction vector. So it should be a vector that is parallel to the direction of the straight line. Okay, so how do we find this u? Obviously, part A should be relevant. In part A, we know that the gradient of the line is minus 1 over 4. What does that mean? That means the line is going down in a way that, remember the definition of gradient. Gradient is rise over run, right? So if you put the negative on top, then the gradient is really minus 1 over 4. So this line should be dropping 1 unit and going across by 4 units. Dropping 1 unit and going across by 4 units. That should mean that our u should be 4 minus 1 or something like that, right? Because as a vector, the top number is x and the bottom number is y. So the top number is telling what direction, how many steps you should go in the x direction, while the second number is telling you how many units you should go in the y direction. So u could be 4 minus 1. Now note that u is not unique, so any other multiple of 4 minus 1 would work. Therefore, if you come up with, for example, negative 4, 1, that is still a correct answer. Even if you come up with something like 8 minus 2, that is still a correct answer. So different students could have different answer to this, but they should be a scalar multiple of 4 minus 1. Okay? Make sure you understand this. Rewatch this part of the video if you don't. This is quite an important concept. This is the second time SL paper have done this kind of thing, mixing vector with normal y equal to mx plus c kind of line. Now the next line actually gave us a hint on how to do part B. It's telling you that the direction vector of y equal to x is 1, 1. Obviously for y equal to x, the gradient is 1 because m is 1. So they got kind of hinting you that if the gradient is 1, the direction vector would be 1, 1. So you could have get some information from there. Okay, part C is kind of difficult. Find the acute angle between y equal to x and L. You may think that since L has a gradient of -1/4 and y equal to x have a gradient of 1, you're finding the angle between a line of gradient 1 and a line of gradient -1/4. But if you think about what we have learned in the syllabus, there is no direct way of finding this. There's no clear method of how to do this. So the best way to do part C is actually using vector. Remember, y equal to x has a direction vector of 1, 1. And from the above, we know that Ly has a direction vector of 4, -1. So it seems to be easier to find the angle between the direction vector 1, 1 and direction vector 4, -1, because there is a direct method provided in the syllabus, which is the dot product. So we will use the dot product. If you go to the formula booklet, which I have one in now, you can't see it because I'm doing a screen recording. Then the formula will tell you that the cosine of an angle would equal to V dot W over the magnitude of V times the magnitude of W. Okay, so there's no dot here. There's no dot here. So we do 1, 1 dot 4 -1 over the magnitude of 1, 1 times the magnitude of 4 -1. So we do dot product. So hopefully you know this. Dot product is the top number times the dot number. So 4 plus the bottom number times the bottom number over the magnitude. Magnitude would be the number square added up and then root it times the other one. So that would be 4 square plus -1 square, which will get 3 over root 2 times 16 plus 1, 17. So that's 3 over root 34. So we'll need to find theta. So theta would be the inverse cosine of 3 over root 34. Okay, so I'll use my calculator. You should get 59.04 degree. Okay. Next, we have f circle fx. Obviously, that's composite function. You want to put f inside f itself. So f itself is 16 over x. 16 over, this is where x is, and you put f inside there. So it's again 16 over x. 16 over x. I don't know if you're good with fractions, but the bigger fraction line, the bigger one means divide. So it's 16 divided by 16 over x. So it is 16 times x over 16. So the 16 and 16 cancel out, and it is x. So f circle f is just x. And D says hence write down the inverse of f. Now, when the exam used the word write down, it hints that you should know the answer right away. You do not need any kind of calculation. As a matter of fact, the inverse of f is f itself. So it's exactly 16 over x. Why? Because from above, we know that f circle f is x. Whenever a function composite itself gives you just x, that function is a self-inverse function. It means the inverse of that function is just the same as the original function. Okay? And as a matter of fact, this question says hence, so you have to use this fact to get your answer. And by you have to means in your working, you cannot show any kind of calculation where you try to find the inverse of f. For example, what's the normal way of finding the inverse of f, right? You would write it as write fx as y and then swap x and y and then make y the subject, right? if you show any kind of working like this in your answer booklet, the exam would consider that you didn't do hands and would not give you any mark. So this is almost the only time where doing working might screw with you. But yeah, conceptually you need to know this. For any function, if you compose itself and you get x, then that means that that function is a self-inverse function. Okay. Next it says hence or otherwise. Now this time there's otherwise. When there is otherwise, that means it's okay to not do hands. So it's okay to do this part without using the previous part if you want to. But obviously using the previous part should be easier. It says find an obtuse angle formed by the tangent line at x equal to 8 and the tangent line to f when x equal to 2. So from above with here, which is part A, we know that when x is 8, the tangent have gradient -1 over 4. We also know that that means the direction vector for that line would be 4 minus 1. Now, I choose to use the vector because from part C, we know that vector seems to be a better way to do it. And so the next is I need the direction vector of the tangent line when x is 2. So obviously, I will need f prime 2, which using the derivative is -16, 2 to the power of -2. So that's -4. So that's -4. That would imply that my direction vector, since -4 means the gradient is -4 over 1, so again, rise over run, means my direction vector would be 1 minus 4, okay? Because run is for x and rise for y. And then I can do the same thing. I can do dot products again to find the angle between these two vectors. So again, cosine angle would be the vector dot the other vector over is 4 plus 4 when you dot, and what is that? Root 17, root 17. So 16 over 17. Therefore, same thing, theta is arc cosine 16 over 17. And so we use a calculator. It is, oh, it's not 16. I mean, what am I doing? 8. So I got 61.93. What that means is my two tangent line make an angle of 61.93. But since question asks for the obtuse angle, so I should come up with the other one, which is obviously 180 minus it. Therefore, the final answer is 118 in 3 significant figures. That's it. Now, if you think about it, I basically did the otherwise method because I didn't use the fact that our function is a self-inverse function. But it seems to be the easiest way. But you can think like, how do I use the fact that the function is a self-inverse function? If you really want to come down to this, if you think about it, how do you find the graph of an inverse function? You would reflect your graph along the line y equal to x. So for a self-inverse function, what that means is your function, the graph of the function would stay the same after you reflect it along y equal to x. As a matter of fact, the graph of 16 of x, so it's a rational function. It's a hyperbola that looks like this, where the graph would be symmetric if you reflect the graph along y equal to x. Then the tangent line at 8, okay, let's assume 8 is like here, and then you draw a tangent line there, okay, kind of look like this. Okay, what about 2? What does 2 have to do with 8? Well, the answer is, since our function is 16 over x, if x is 8, then that's 16 over 8, which is 2. So this point actually have coordinate 8, 2. All right? But if you're reflecting it along the line y equal to x, where would 8, 2 goes to? Well, 8, 2 would go to 2, 8. So the point 2, 8 is on the inverse. But remember, the inverse is just the original function. They're the same. Therefore, we know that if you want a tangent at x equal to 2, you would get it there. And these two tangents are actually symmetric of the line y equal to x, simply because the original function is symmetric of the line y equal to x. And from the previous part, we also found that the acute angle between y equal to x and our tangent line at 8. So we found that the acute angle of this line, y equal to x, and the tangent at 8, 2, has an angle of 59.04. Due to symmetry, the other side of the angle is also 59.04. All right. That means the obtuse angle between the two tangent lines is just 2 times that. And if you press the calculator, you would get 118, which is the same as what we got. So the fact that it is self-inverse, and also you need to realize that when x is 8, the function would have a y coordinate of 2, and therefore this point would flip to 2 when x is 2, is how you use the hands. That is a really tricky hands. Therefore, I think most of the students would better off just do otherwise. And that would be it for this video. Another day, another video.